Hey YouTube, I'm getting just about to the point where I've wrapped up my lithium titanium oxide battery bank. This project started because I had a very specific design constraint which wouldn't be served by commercial off-the-shelf solutions. The main constraint being I wanted sub-zero performance, the ability to get either DC or AC power into a unit and monitor under somewhat remote conditions through some kind of a wireless uh, monitoring system. So I've built this project out over the past year or so. I've had plenty of time with the pandemic and everything else. And ironically enough, despite the polar vortex, which has seemingly frozen over the Gulf Coast, um, weather in Canada has been kind of cold, kind of warm in my part of Canada, and I actually missed a good opportunity to test this in very sub-zero conditions of minus 20 degrees, just because I was too busy with work and trying to keep everything from falling apart in said sub-zero conditions. But, c'est la vie. This video is going to be the finale video for this project. I've done enough build logs, and quite frankly, I do want to move on from this project now that it's done to a state where I'm good enough with it. I don't know if I'm ever going to do kind of a revisit or a version 2 of this. I just want this to be done so I can move on with other stuff, and I'll get to that at the very end of the video. So, time for a little walk around of this thing, and take of it what you will. You may learn some interesting techniques which you can use to apply to your own projects, or you may say, why on earth would you do this because it's so inefficient? You can just get a Jackery power unit that gives just as much, if not more, watt hours in a smaller, lighter unit. Again, very specific design constraint of sub-zero performance that cannot be served by lithium iron phosphate or lithium polymer or NMC or any other lithium battery chemistry other than LTO, unless I go the extra mile to buy a battery which has built-in heaters, which I don't really want to have to deal with. So, nevertheless, let's dive into this. Before we get to the inside, let's talk about the outside of this project. This started with me choosing this DeWalt Tough Case DS, is it a 350 or 450? One or the other. I chose this because it was a affordable price point and I didn't want a super bright red Milwaukee, I forget what their system's called, but basically their modular tool case system. I wanted something that was rugged enough, waterproof, and otherwise fit the bill. So I settled on this. On the outside, it's pretty much stock except for two little modifications, so otherwise it is waterproof and weather resistant to the degree of a stock DeWalt Tough Case. The only modifications being on this side, which are a DC power port for power input and output, as well as an AC power outlet, which is a Neutrik power con. This is a outlet for the built-in inverter, so I can keep this covered when it's in travel, plug in the power con, and I'm not intending on using this in situations where it's getting directly rained on, so I decided not to use a Neutrik True 1 power con, which would have probably been a better choice in retrospect. Now, this connector I will want to replace. I'm not going to do a version 2.0 or revisit on this, but I do want to replace this connector with a higher quality connector. These are known as SP13 connectors. They are not particularly the greatest. These are relatively cheap, a couple bucks a piece, and they're waterproof enough. My issue with them is they're nylon and relatively easily strip the threads on the bulkhead component. So you can't tighten it down super hard, and that means that if you've got a cable plugged into here and someone trips on it, it could actually yank the bulkhead connector out, stripping the back nut. And then now you've just got this naked connector dangling out, and you can get environmental ingress into the case. Additionally, I would have liked to pick a connector that had female pins instead of male pins, because this does connect to the fuse panel inside. It is fused, so if someone does jam metal against it, it will short out and just pop the fuse. So I'm not too worried about that from a safety issue. It's more just an aesthetic / it should be designed a different way. These are SP13 connectors, and I honestly will just eventually get an LP20 connector. It's a 20mm connector, very similar to a Neutrik in screw-in style. So you put 4 bulkhead screws, and it's a circular connector that push-clicks in, kind of like an XLR, but not really. I digress. I could go nerdy about connectors for hours on end. Alright, I've gone ahead and popped the latches open to save you from the lovely sound of those things on camera. These steel hasps are pretty durable, though I have heard stories of contractors shearing these off by hitting them while they're kind of popped out like this, snapping the plastic here. For my use case, I'm not in and out every single day, so it's a risk I'm willing to accept. Either way, let's pop the lid open. I've tried my best to organize this for my use case, and I'm going to explain the layout from the right-hand side to the left-hand side, and then we're going to look at the internals, though not too much has changed. Either way, starting from the right-hand side, we've got a Blue Sea Systems... No, is this a Busman? No, I think this is a Blue Sea Systems. Either way, it's a thermal breaker rated at 150 amps. The battery management system is rated at 200 amps, so that takes the function of a magnetic trip breaker, and this is just the thermal for sustained overloads. Either way, we have the ammeter / coulometer and the remote head module. We have the inverter power switch, a small little breakout for all the Anderson power poles with individual circuits, fuse box, some wires that I haven't quite zip tied down yet. I still have to finish 1 or 2 things here. A cable tie down that really doesn't want to stay in place even though I've primed it several times. And that's the internals. So in operation, all you really have to do is pop the lid, flip that breaker on, and your remote head unit comes on. Then at that point, you can power up your inverter and you're good to go. You have AC power on the output. The AC power is accessed with any number of PowerCon adapters, including some power bars that I have here in this convenient little tray that comes with the box. I've gone ahead and extended one of the 2 battery balance cables to allow me to use external balancing devices or just cell meters to measure the individual cell levels and balance them out as necessary, especially because I'm going to be thrashing it in sub-zero conditions whenever I do bring it in for a full balance and charge. I'm going to want to get those cells as leveled out as I can again, just to maximize the capacity. Again, I'm going to put the caveat that I am not intending this to give me maximum power density. This is intended to give me reliable AC and DC power at sub-zero conditions in a no matter what situation, mainly because I eventually want to get a radio astronomy and I do not want to make a long trip out, set up all my equipment only to have my power source kind of crap out on me. Either way, the Juntech meter itself, I designed this magnetic mount and I glued in a plate into the lid that acts like a home for it, which is very convenient. The magnetic mount also means that I can put it in other positions, such as just on this, well, you can't see it from that side, but I'll put it over here. You just put it on this latch and leave the lid propped open if there's no bad weather. Or, if you've powered this from a separate USB battery bank or something, you can even attach it to the lid, and it is magnetically attracted to the lid through the plastic, because again, neodymium magnets, great for that. Either way, by default, it lives in here and always gives you voltage readings from inside the case. This is also designed to measure the total charge, so once you've charged it up to full and reset the capacity, you get about 27 amp hours no matter what the temperature is. I've tested this at 25 to 30 degrees ambient. I've tested this down at 0. I've tested it around -5. The inverter does warm up, but the batteries do stay pretty cold, and you get, 27 amp hours no matter what. I will also put the caveat out there that these yin-long cells do give me about, I would say, 35 to 38 amp hours, but my main limitation as to why I can't get the full 35 to 38 amp hours out is because of the inverter. So if I was to use DC power, I can pull a lot more ampacity out of those cells than I could with the inverter. Having said that, continuing on to the left, this fuse panel, the side connector for the DC power is tied into here, so I can apply power directly in and charge the battery in reverse through the coulometer, through the circuit breaker, and everything else. So if anything bad happens, the breaker, the fuse, and the BMS are all going to take care of any issues. Plus it's such low gauge wire, this wire is practically a fuse on its own. Either way, I can also withdraw power from that, and this meter will keep track of the state of charge. The nice thing is, the statefulness of this system is kept in the coulometer, not in the display unit. This is just a display unit. It's a headless module. You can unplug this and power cycle it when you're moving it from power source to power source. So say you've discharged at 50% and your system clock is running at 10 hours. When you plug it back in, it will show you the current system clock. It will show you the state of charge regardless of whether you've power cycled this or not, which is quite a nice feature in my opinion. Yeah, it came back at around 4 minutes 20 seconds. Nice. Either way, I think that's about it for the lid. The layout is as clean as I can make it while still making everything really easy to access. In terms of the tray, I do want to maybe trim down and remove one of these two power bars, because again, for the DeWalt memes, I picked a yellow power bar, modified it with a PowerCon receptacle. I have just a regular NEMA L515 power cord to PowerCon. I have a PowerCon A to B, and I've also got this relatively cheap looking power bar, the PowerCon B on it, as well as the just a straight NEMA 515 female single plug. So I've got plenty of options that I can store in the lid, as well as DC cables, such as some banana plugs to PowerCon, Anderson Power Pole cables, which I can use for other purposes that I'll get to in a bit. Either way, I've got this set of flying leads that's the balance cable. I do want to see if I can do better with this. I'm not a great fan of this, but it's a small improvement that I can make for the future. Either way, let's dive into the inside. Alright, now that we're inside the box itself, the same Yinlong 40 amp hour lithium titanate cells. Again, the extended leads. I do want to clean up this arrangement just to make it a little safer. Maybe provide some strain relief to hold this along the side of the enclosure. Minor things that I want to do, but not a high priority because I just want to get this video done. Either way, the same bulkhead mounted fuse. It's a 200 amp mega fuse with a 200 amp BMS, so no matter what, one of these things will trip out, with this fuse being the last. Actually, I think it's a 300 amp fuse. I'm pretty sure it's a 300 amp fuse. Either way, we've got the inverter. Again, not much has changed. I have printed this small little piece of plastic just to wedge the temperature sensor in place against the heatsink of this inverter. I could put this temperature sensor against the cells, but I am more concerned about this overheating than this being too cold. In the winter, this inverter honestly acts like a little internal heater, which helps keep the components at least mildly tepid instead of, straight up -20. But drawing current from this at -20 or charging it at -20, not a problem from the 10 to 15 times I've already tried cycling this out on my balcony. Either way, I do want to try and get a shorter RJ11 4-pin cable for this, but not super high priority in my opinion. I do need to tie this off, but yeah, not a huge amount there to worry about. I do have wish lists of things I want to do in here, but again, they're not super high on the to-do list. I've got other projects that I want to get underway. So I think that's about it for this video. I've designed a system that just works for me, and it's honestly not going to be right for everyone. take of this what you will. I'm going to take this as the middle of the video and just provide a slight intermission. If you enjoyed this series about my LTO battery bank build-out, do leave a message down in the comments, like, subscribe, all that stuff that keeps the algorithm happy. Either way, I'm going to then segue into talking about learning experiences and little tips and tricks from building this unit out. So let's pop back in this direction. Okay, so time to talk about lessons learned. First thing is, I honestly wish that more case providers would provide digital models of their product. Honestly, if DeWalt published schematics, or not schematics, but a CAD file showing what the inside of this looked like so I can design parts to fit and latch onto it, my life would have been so much easier. I wish more retailers would do that, but I mean, it's not really in their best interests, I suppose. They might be worried about people stealing their design, or they might be worried about people making counterfeits. All sorts of reasons, but, you know, it is what it is. Honestly, you can publish the design of what this box looks like, but it doesn't teach someone how to make a counterfeit with good injection molding quality. That's almost a black art in itself, to get the right temperatures and the right flow patterns and the right polymer blends to make a good product. So you're still going to get good quality by buying the original and not some knockoff that, you know, someone tries to pass a counterfeit DeWalt instead of a DeWalt. I guess lesson number 2, fixing items to this polypropylene plastic. Polypropylene is great, high impact resistance, really hard to bond to. 3M Tape Primer 94 is great not only for VHB tape, but also for cyanoacrylate. However, cyanoacrylate and temperature cycling don't necessarily mix well together. Certain elements in here have actually just shrunk in the cold and just popped straight off. The VHB bonded components, never a problem. The fuse block and the circuit breaker are bonded on that kind of have like a C grip with super glue or cyanoacrylate around prime surfaces. Those ones don't seem to pop off, but this item, this item, this item, and that item have all come loose a little bit when I've temperature cycled it down from -20 up to +20 and back and forth again. So that's kind of my lesson number 2. Just because you can get it to stick really great on polypropylene with Tape Primer 94 does not mean that it will stick well at every temperature. And VHB tape is incredibly forgiving for temperatures as well. Lesson number 3, connectorize things more. I honestly wish I provided myself a means to disconnect this battery pack and BMS from the rest of this so I can just yank this out as a module, set it aside, and work on this as a inert system. But as I built it up, eventually I committed to bolting this battery pack in here, and everything from that point on was working around an energized battery pack that could provide 1200 amp short circuit current as part of its design spec. It would short out to 1200 amps and not damage the cells. You would have to short out with higher short circuit current because these 40 amp hour cells provide 30 C of continuous duty current just fine. That's what they're designed for, and it's a little absurd in my opinion. I kind of wish I went for prismatic cells. Going on to lesson number 3. Cell design. Cylindrical cells are great if you want to force air cooling or kind of do a higher current design. The radial nature of these cells provides more current capacity relative to a prismatic cell from what I've seen, at least with LTO cells. It's also kind of hard to find LTO cells that fit this form factor. So, another lesson learned, I wish I started with the form factor of the cells and built it around and selected a box based on that. Another lesson is when you're picking an inverter, you might want to choose an inverter that can utilize the full voltage range of these cells. I thought it would. Unfortunately, I couldn't. C'est la vie. It's already mounted. I'm not redesigning this whole thing to squeeze an extra 10 amp hours out of AC power when I can still squeeze out the full wattage of the pack by using the DC power, which is going to be my main application anyways. So, am I worried about that, little lack of capacity for AC power? Not so much. This will fit the bill just fine. What other lessons learned that I want to talk about? I think one other item that I want to do, and maybe this isn't so much a lesson learned, but more of a wish list, is reverse engineer this little button box to control the inverter. So there's two LEDs and a power switch on this little 4-pin cable. Reverse engineer that and give myself some weatherproof buttons on the outside of the box, because it's really annoying to have to pop the latches, lift the lid up, and power that on. However, no matter what, if I'm taking this out from a storage state, I have to do that anyways, because this breaker cannot be remoted over to here without carving lots of holes in the plastic body and having to design more and more weatherproof sealing surfaces and areas on this case. It's just kind of this really awkward situation of, it would be nice to be able to turn the inverter on and off. Once this is on, I can close the lid and leave it, and then I can just power cycle the inverter as I need to from a side control panel. So I think that's most of the lessons learned. I don't feel too bad about this. The things that I do regret with the design are not making it easy enough to remove components. I wish I designed the rails here that mount this headboard of electronics to be a little bit more serviceable. It would have been nice to design rails that glue onto the sides with VHB tape and have little turn latches so I can turn both latches and slide this whole module up and service it. And then when I'm done, slide it back down and latch it in place. Would have been nice. Unfortunately, I've committed and I've glued them in. Could I take it apart and rebuild it? Absolutely. Small tip as a side note, if you're ever trying to remove VHB tape and you can get underneath it, don't use a knife and scratch and gouge the surface. Take some dental floss, slip it under, and then just wiggle that floss back and forth. The dental floss will work through the acrylic foam in the center, and it won't get seized up on the two adhesive pads, or the adhesive surfaces on the outside. It'll just cut straight through the acrylic foam, and you're left with residue on both surfaces, but you can clean that up with some rubbing alcohol and some paper towel or scrubbing pads. Complete tangents aside, what else? I think the only other thing that I regret is not having yet come up with a replacement decal for the front, because this is technically an adhesive decal that I could remove and replace with something else. I am honestly tempted to take the DeWalt logo from The Expanse. Spoilers, there's a ship in Season 5 of The Expanse called the DeWalt. I kind of want to take that logo, print it on vinyl, and put it on here just to see who gets the reference. But that is a future me problem for when I've got the disposable income to worry about this. So, going back up to here, I think that's about it for this video. Alright, so if you've stuck around for this long, I do appreciate your views and commitment to watching this entire build log series. Take of this what you will. This project fits a particular niche need. You design and build the project that suits your build objectives. Otherwise, do the things the algorithm likes. Like, subscribe, comment, hit that notification bell, and otherwise just enjoy these videos as you will. Before I cut this video off, I'm going to mention two things, both of which are related. The first item is that my goal is in the next couple weeks to push out a huge rapid-fire round of airsoft-related videos. And that leads me to the second issue. If you have been paying attention to the airsoft world, you will have probably heard about the Canadian Bill C-21 and the challenges that poses to the Canadian airsoft environment, the sporting community, and as well as the business community. No matter what you think about firearms, no matter what you think about airsoft, if you are a viewer or subscriber or a fan of this channel and content of this nature, there should be some key things that concern you. The most of which is the role of government and the application of legislation. Having taken a lot of time to study Bill C-21 word for word versus the claims in the public, I can quantitatively say it's a pretty bad deal for all Canadians, even if you do not enjoy airsoft or paintball, even if you do not have any interest in firearms. The bill is inherently a division between evidence-based decision-making and decision-based evidence-making. The clauses in the bill do not fit the problems they're trying to address. As a maker, you should be concerned as to what happens to the environment around us, what happens to the things that we use, like 3D printers, like in the corner over there. What's to say that the government doesn't decide, oh, well, 3D printers can be used to make dangerous things, so we're going to ban 3D printers. It seems a bit hyperbolic, but, you know, there's been discussion about that as well in the law enforcement community. There's significant concern about 3D printed guns and the, you know, threats to traceability and criminal activities that may result from that technology being used and misused. But think about the positive uses that 3D printers have brought in the world. So much innovation in the last decade, ever since one of the very first commercially available 3D printers for hobbyists, the MakerBot Cupcake. Think about in the early days of the COVID pandemic, the very rapid response and rallying force that the maker community had to design a 3D printable component that allowed you to put acetate sheets as the front face shield to issue to hospitals and nurses so that they would have PPE when supply chain was still reacting. It's a little bit hard to imagine, but being an airsofter, being a maker, being a avid studier of the civic process, I do have significant concerns about the divisions of power and the way that if this is upheld in, you know, the various levels of court, all the way up to the Supreme Court of Canada, if challenged, and I'm pretty sure it will be challenged if the bill passes, what's to stop the next government from, say, passing legislation eroding workers' rights at a municipal level, or eroding environmental protections, or eroding certain traffic laws to provide safety for communities? Certain standards should stay at a federal level. But in this case, it's a feel-good voting thing versus an actual address to a problem that Canadians face. And don't get me wrong, Canada faces a gun violence problem. We are not that much better than many other parts of the world. So, warts and all, if you've stayed along for this part of the video, I do really appreciate you listening, and otherwise, peace out.